Hi everyone, my name is Shubhodit Shah. Welcome to our YouTube channel Helm of Science. Yesterday, your West Bengal joint entrance exam happened. Hopefully, you all gave a very good exam in each every subject, and your result will be as per your confidence and as per your quality. So, best of luck for the result. Okay, so apart from that, apart from coming my video, I have to say something. That first one is typically in organic chemistry, I made video of organic chemistry questions only. I can say, or better I say, that the question was not easy, and as well as the question was not hard. The question was moderate question, and that is actually moderate question actually identify who have studied or who have not. So these types of question actually identify who worked hard. These types of question actually identify who have worked hard. So if you will work hard, then you can solve these types of question very easy manner. Okay, so in this video I am not going to the detailed explanation of each and every question because there is a lot of questions. Okay, and I cannot go in that explanation very deep manner. So I just explain the just tips and tricks or the idea of how to solve the question. Okay, so before starting the video, I want to say that don't take any pressure. Maybe I am wrong. I am just solving the question with as per my knowledge. Don't panic, don't bother, and don't tense. You gave your best yesterday. And you will get the result also as per your exam. Okay, so I am starting the solving each and every question. So our first question of the session is based on boiling point. This is the question number 41, and they gave us the increasing order of their boiling point. Firstly, I am not going to the detailed explanation. All means have a OH group, and we know that OH group can show intermolecular hydrogen bonding, intermolecular H bonding. Fine. If some compounds show hydrogen bonding, the boiling point is maximum. So in between among four, it has the highest boiling point. Now next, butanone. One means what this does means one means a carbonyl group. Okay, and carbonyl group is a polar bond, is a polar compound. After hydrogen bonding, polar compounds have higher boiling point. So in between three, next higher boiling point is this butanone. Next, between these hydrocarbons, very carefully, N-pentane has a straight chain. Fine, N-pentane has a straight chain, and iso means a branch. This is a straight, and this is a branched. Fine. If this is a branch, we know that the Van der force of attraction will become less, and in case of straight, as the surface area is also increasing and the Van der force is also increasing, so the boiling point becomes high. So the option B is the correct answer. So option B is our correct answer. The first have higher, this is highest boiling point, and this isobentane has lowest boiling point, which is okay. Fine. So our next question is the maximum number, question number 42. They have asked the maximum number of atoms staying in a plane in para-nitrobenzonitrile. Fine. So what happened? Look at very carefully. This is a cyanide, and this is a sp3 carbon, and this is a sp3 also. This is a sp carbon. This is also sp. Fine. So what happened? If they both are sp, they are in a plane. in a plane, and we know that the all hydrogen and carbon of benzene are in same plane. Okay, and these three atoms also in same plane, because we know that nitro group can participate in resonance because of their prenarity. If there is any group, bulky group present in this ortho position, then this NO2 will not in plane. That is steric inhibition of resonance. But here the steric inhibition of resonance concept is not come in the picture, because there is no any bulky group present in the ortho position. So nitro group is in plane. So the total number of atom in plane is 1, 2, 5, 6 carbon. That means 8, 4 hydrogen, 12, and 1 nitrogen, 13, 2 oxygen is 15. So option D may be the right answer. The maximum number of atom can be present in this plane is 15. Fine, write it down. So this is our next problem. The problem is based on our stereochemistry. That means the relation between two molecules, that is enantiomer, diastereomer, homomer, or constitutional isomer. We know that this is came from isomerism, chapter isomerism in class 11. Okay, fine. That means stereochemistry. Fine. Look at very carefully. This has single carbon. So we can rotate it like that. If there is a 2 carbon present and the both above and below group are not same, so we cannot rotate. But in case of single carbon or a single carbon in a Fischer projection, and we can rotate. If we rotate 180 degree, what happened? This COH group came on this position and this CH3 came on this position, and OH and H alternatively change their position. So here H will come and here OH will come. So we can say after the rotation, very carefully, after the rotation, these two molecules become same. These two molecule become same. So they are homomer. Fine. Homomer. The rotation is needed. Rotation is very carefully. If you not rotate and can say this is a mirror image, that is not correct. Okay, this is not a mirror image. So this is a homomer. Fine. Now next, you can say that sir, it has a plane of plane and it has a mirror image each other. But if you can rotate, first check it after rotation. You can easily rotate it like and give and can give this structure. If I rotate the molecule, it look like this way. If I rotate this molecule, look like this way, then this NO2 will come in this position. This is also meta position, so there is no problem in it. And again, this molecule, both are same, so they are also homomer. Fine. And lastly, very interesting, this is not a diastereomer, because here we cannot apply cis-trans concept because the connectivity of molecules are different. Because connectivity of molecule means here both chlorine is connected with this carbon. Both chlorine is connected with this carbon, but here the chlorine are not attached in the same carbon. So this is not diastereomer. Diastereomer only applicable if the all connectivity of atoms are same. Then also then only the stereoisomer concept will become enantiomer, diastereomer, or homomer. But there is a connectivity as different. So this is constitutional isomer. Constitutional isomer. Fine. So this is our answer. Check it the option. Okay. Fine. Now I am going to the next problem. So our next problem is based on acidity. I have told you many times that one question can come from acid base, only on acid base. So fine. And I have made a video on the acidity of phenols also. You can check the link in our description section. Fine. So they have asked the question that the acidity order. Fine. And I have clearly told you that if there is any acidic group, that means C double bond OH, anything present like that, C double OH, that is carboxylic acid, is present in any group that is highest acidic in nature. that is highest acidic may have it have not resonating structure, it has no hyperconjugation, whatever it is, but in case of COOH, because of if it is released H minus, this can give you equivalent resonating structure. They give you equivalent resonating structure. That is why it is become most acidic in nature. Then negative charge came on electronegative atom. So either negative charge come on this carbon and maybe this oxygen and maybe this oxygen. Fine. So we know that oxygen, negative charge on oxygen is more stable than carbon. So in between that, the acidity can compare. Fine. This O minus is stabilized by the NO2 through resonance. It will show. I am just showing the resonating. How will it resonate? It resonate look like this way. Fine. So this O minus becomes stable due to the resonating structure. So next, after that, this become more acidic, and we know that this is least acidic because the negative charge come on the carbon atom. So option D, you can check the option D will our correct answer. Fine, check it properly. The next question, the question number 48, came from our biomolecule, that means amino acid and peptides. Okay, fine. Now what happened? Look at very carefully. They asked that how many dipeptide can form from these two amino acids, that means glycine and alanine. And we know that first thing we know that glycine is an achiral amino acid, except glycine all are chiral amino acid. So look at very carefully how a peptide bond will form. This NH2 has lone pair. This NH2 will attach to the carbonyl center of this carboxylic acid and OH group leave. Fine. So very carefully, look at very carefully. There is two NH2 group and there is two CO2H group. So there is a two possibility of forming a dipeptide. One is coming from one dipeptide can form from this NH2 group, and other was this NH2 group. Fine. First I will show first this one. Okay. This if this NH2 group will attack, this OH group will leave, then what happen? NH2 CH2 C double bond O, this NH bond, okay, it eliminate as water, one hydrogen from this and from their OH. This CH and CH3, fine, CH3 C double bond OH. Okay, first one, this one. Another one possibilities is that I am writing it here again, the structures. Fine. I have just changed it. Here I will give the COH and here NH2 and NH2 attack this. I have write it like this way. So CH CH3 NH2. Fine. Now this NH2 will participate in the reaction. This OH will go, and after elimination of water, what happens? CO2H, CH2, NH, CO, CH, CH3. So option 1 and option 2, both product can be possible from these two amino acids. So this is a very interesting question, and it is also very easy question, not a too much hard question. It's a moderate question. So you can easily just identify the reactive center. First you have to identify the number of reactive center. From that you can easily say that there is a two product can be formed. Fine. Check it the option carefully and write it down. Our next problem came from the chapter Carbonyl. I have told you very much, Carbonyl chemistry is a huge important chapter. Fine. First what happened? This is methanol, and if we give the H plus, then what happened in presence of methanol? First attack look like that. OH, OCH3, fine. Okay, then what happened? Then H plus, this dry H plus, presence of dry H plus, this become a good leaving group, and further CH3 OH will attack and water will leave, so we get acetal group. We gave an acetal group. Just a second, I have to check the option. So right, I am right here. This is a acetal group. So option B and D may be correct answer. So the option this is product A. Fine, acetal. After that, what happened? They will give us dilute HCl. In presence of dilute HCl, this protection will leave, and we get our deprotect product. That means we will get again a benzaldehyde. Fine. After benzaldehyde, after the formation of benzaldehyde, they give us, pause the video and write it down the mechanism. I have to rub it. Fine. After formation of benzaldehyde by using dilute HCl, what happened? They give us acetic anhydride in presence of sodium salt, NaOAC, or sodium acetate, presence of sodium salt. This will give you the tranexamic acid. This will give you tranexamic acid, and this is reaction, this name reaction from the benzaldehyde. If this reagents is only applicable on aromatic aldehyde, if there is a CH3CHO, that will not become CH, that CH3CHO will not produce this acid. This reaction is occur only in presence of aromatic aldehyde, and this reaction is a famous name reaction, that is a Perkin name reaction. This is nothing but a Perkin name reaction. Today's video I will not go to the details mechanism of Perkin reaction, because the video will become very high, so very time taking, that become very boring. You have no patience to see the whole mechanism. You have to patience to know the actual answer and how to go to the approach of answer. So in benzaldehyde, if you add acetic anhydride and sodium salt, we have get a Perkin reaction and we get a cinnamic acid. So option D, I think option D, check the answer also. Option D is our correct answer. Fine. This is a very important question. It's a very good question. It's a good question. Question number 72, and it came from alcohol, phenol, and ether. Fine. Or maybe you can say this reaction mechanism. If we give dilute HNO3 in case of phenol, if we give dilute HNO3, what happened? We get our nitration product. That means this one. Fine. After that, this is X. After that, what happened? They have zinc metal in HCl. If we add metal HCl in nitro product, we get a reduced product. That means reduction will take place. The reduction will take place, and we will have NH2. Now they give us acetic anhydride. What happened? Very good, carefully. CH3, C double bond O, CO, CH3. This is acetic anhydride. This NH2 group will attack on this carbon, and this will leave, and we have protected NH2 group. That is, this acetic anhydride is added because of the protection of NH2 group. NH, CO, CH3, and what is our side product? Our side, this is a Y, and our side product become CH3, CO, OH. That means acetic acid. Fine. So this is a very good question, came from alcohol, phenol, and ether. This is a simple. The first nitration takes place, then the reduction will happen. After the reduction, we have to block or protect the NH2 group by the acetic anhydride. Fine. Checking the option. That is, checking the option. the next reaction based on name reaction and reagent. Look at very carefully. This is a alkane and this is not a terminal alkane. This is a non-terminal alkane. If we give sodium in liquid ammonia in presence of ethanol in terminal alcohol, what will happen? This reaction will happen. Birch reduction. Birch reduction will occur in sodium in a liquid ammonia and ethanol. Fine. So what happened? We get in presence of sodium and liquid ammonia, we get this reaction goes via the radical mechanism, and we have transalkene. We know that everything that gives us transalkene. Fine. This gives us transalkene. If there is a dival H, then we have cisalkene. So I am not going to that. This is transalkene, and they will next give us the basic KMNO4. Very good, very important part. KMNO4. Sorry. Basic KMNO4. Basic KMNO4. What actually happen if there is acidic KMNO4? Then this bond will cleave. This bond will totally cleave. There is no CC bond. 2 OH group will present in this carbon, and we have eliminated water. But in the basic KMNO4, we have to see the scene addition. We have to say scene addition. If we have scene addition, then we get like that scene addition. That means after the scene addition, we get our THEO product. That means the methyl group are in AC, then OH and H are in different, that is stereoisomer, not isomer. If dival H plus will give, they will give dival H plus, then erythro product will be formed. This is a stereoisomer, and this will go by a scene addition. Just a second. So in this case, this stereoisomer, there is 2 stereoisomer present in option, that is B and C. Both can correct. Okay, this is our second last problem, and I will go to the next last problem based on the carbonyl chemistry again. This is our last organic question of our exam. So what happened? Look at very carefully. Okay, fine. First, they gave us Mg ether in this compound. So what happened? Look at very carefully. Okay, I am going to the details mechanism. First, Mg ether. What happened? Mg Br will form, and this carbon become electronegative because this carbon is attaching with a metal. If any carbon attaching with metal, this carbon become a negative charge, and it can act as a nucleophile. Fine. Then they will give us acetaldehyde. Okay, CH3 CH2. This is also question from carbonyl. That is why I said that carbonyl chemistry is the most important chapter in terms of competitive exam. This minus will attack and these bonds will open up, and after the H3O plus, adding H3O plus, what happened? Sorry, CH3, this minus attack this carbon, C, OH and CH3. Fine. Okay, after that what happened? Br2 NaOH can oxidize this one, so we have CH3CO CH3. Fine. After the oxidation, what will Br2 NaOH do? This has a CH3 group, and in presence of Br2 NaOH in basic condition, and if there is CH3 group present in carbonyl, then halloform reaction will take place. Halloform reaction will take place, and we have acid in this position. Fine. So this is one product and this is our another product. So this both is present in our option B and D. Fine. Next, what happened? Very carefully. They give us SOCl2. Okay, SOCl2. That's okay. Fine. COCl. Okay, CH3. And if you give us NH3, this NH3 will attack, look like that, and minus HCl is going to happen. HCl will removing, and we have. Okay, now I am rubbing this one. Pause the video and take it very carefully. I just rubbing the first step. Okay. Fine. NH3. If HCl will remove, what happen? We get a amide. Fine. We get a amide. And if we give Br2 in presence of NaOH in amide, then what happen? Hofmann degradation take place. Hofmann degradation takes place. That means one carbon less amine. This amide, this reaction leads to formation of amine from one carbon less than one. This will form amine from a amide. That means one carbon will remove actually. That is why this is a degradation reaction. Okay. So this is our final product. I think this is Y. If this is our final product, so option B and D will our final product. So there are all question I have done in the video. I have detailedly discussed everything with how do you approach this question, how the answer will come. So check it properly, carefully, and don't tense in this situation. Your exam will be very good and you will have a good result. Fine. Thank you for watching and keep practicing. Then is the, you can see the practicing is the main key of success. Fine. Practicing is, I have always said that practicing is the main key of success. Fine. Thank you for the watching.